Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter Combustion, Fuels and Flame. So in this session we are going to see about combustion of combustible substances and their ignition temperature. We know that some materials catch fire as soon as they are brought near a flame, but some materials take a long time to start burning, though they are kept near the flame. Isn't it? Have you observed these substances? Some substances like petrol, these catch fire very easily when they brought near a flame, isn't it? But there are some substances like wood, logs, these all. They take a longer time to start burning even though they are kept near a flame. So in this way, there are two types of materials. Let us explore the reason for the difference in burning of combustible substances based upon the following activities. Why some substances they catch fire very easily and whereas some others they take long time for starting burning. Okay, take a piece of paper and burn it using a candle. What happens then? The paper immediately catches fire and converts into ash. It produces heat energy and finally ash will be remained. Paper completely burns off. Now, can we burn a paper without the help of flame? No, we cannot. Generally, we cannot burn a paper without a flame, but by using some substances, we can do it. In the presence of sun rays, also, we can burn a paper. Burning a paper with sun rays. On a sunny day, go out and focus the sun rays on a piece of paper using a magnifying lens. Then touch the spot after some time. How do we feel? We feel very hot at that place where this magnifying glass focus is on the paper. If you touch at that place, it will be very hot. We continue keeping the same way for few minutes. Then paper starts burning. It catches fire and starts burning there. So without a flame also, we can burn a paper in the presence of sunlight, sun rays by using a magnifying lens. What we are doing here? We are focusing the sun rays on a piece of paper by using magnifying glass. Because of this, that paper will catch fire and starts burning. We might have heard about people in ancient times rubbing pieces of stones together to produce sparks, and hence they produce flames. By using those, they will cook their all works and food needs, isn't it? So what they have done there? They rub the pieces of stones one another and they produce some sparks. By using those sparks, they start burning the fuels. Have you ever tried this? Take two stones, rub two stones hard together and touch them. After rubbing certain few minutes, few seconds, if we touch those stones, we feel warm. What's happening then? When you rub those one another continuously, they become hot and finally they produce some sparks. By using the sparks of fire, they burn fuels. Okay, that was done in the ancient times. On the basis of these observations and previous experiences, we can conclude that a combustible substance has to be initially heated to catch fire or burn. After heating to certain temperature only, that a combustible substance starts burning. Until and unless it is heated to a particular temperature, even though it is combustible substance, it won't catch fire in its own. So the temperature, the lowest temperature at which a substance catches fire is called its ignition temperature. So any combustible substance must be heated to its ignition temperature. Then only that catches fire and starts burning and continues burning there. Until and unless it is heated to its ignition temperature, even though it is a combustible substance, it won't catch fire. Okay. So the lowest temperature at which a substance catches fire is called its ignition temperature. This ignition temperature will be different for different fuels and combustible materials. That is why some substances they catch fire even at very low temperatures, and some they need very high temperature, then only they starts burning. Okay, when a substance starts burning, heat is produced and it helps to burn the substance continuously. The ignition temperature is different for different substances. Okay, some substances they have very low ignition temperature. That means they may catch fire at very low temperatures. For example, CNG, petrol, these substances they have very low ignition temperature. So they start burning at very low temperatures, they can catch fire easily and they continue to burn. But there are certain substances which have very high ignition temperature. For example, logs of wood. So they should be heated to very high temperature. Then only they catch fire and continues to burn. So different substances they have different ignition temperatures. The ignition temperature of substances decides its quickness of catching fire, isn't it? The one with a low ignition temperature catches fire very quickly, and the substances which have high ignition temperature they catch fire very slowly. They should be heated continue for long time. Okay, the substances which have very low ignition temperature and easily catch fire called inflammable substances. The substances or the fuels which are having very low ignition temperature and easily catch fire are called inflammable substances. You might have observed these words on certain tankers on the roads. They'll be carrying some chemical substances on like petrol, CNG, and some other chemicals. On those tankers, it will be written highly inflammable. There it means the chemical substance inside the tanker is having very low ignition temperature and may catch fire very easily and blast into burning. So we should be very careful with such kind of substances which are called inflammable substances. Example for inflammable substances are petrol, alcohol, liquefied petroleum gas which is called as LPG commonly. These all have very low ignition temperature. They can catch fire very easily at very low temperatures itself. That's why we should handle them very carefully. They should be preserved and stored in safe positions. That is why only on the tankers which are carrying these chemicals will be written on them as highly inflammable. If you observe any vehicles like that, we have to be very cautious with those. No fire should be brought near those. No spark should be produced at them. So if they are produced, immediately the substance inside of those they catch fire and they may cause explosions. Fire accidents may occur. That's why we have to be very careful with the inflammable substances because they have very low ignition temperatures and they catch fire very easily. Now let us see some more points to understand very clear about this ignition temperature. Take two small paper cups. Okay, pour water into one of the paper cups and keep the other cup empty. Now put these two paper cups on different tripod stands and heat these two cups with the help of candles or burners. What do we observe then? What happens then? Yes, the cup without water means empty cup starts burning quickly as it reaches its ignition temperature on supplying heat. So when we heat this paper cup without water with a candle, immediately it reaches its ignition temperature and continues burning. It catches easily fire and continues burning and will become ash very easily. But the other cup, which is having water in it, it doesn't catch fire easily on the basis of ignition temperature. because it is having some water in it. That's why that paper cup does not burn. Why? Because when heat is supplied to that cup with water, the heat is received by the water present in it. Okay, when we heat both the cups, the cup without water, it is taking completely heat given by us in the form of candle flame. So it reaches its ignition temperature immediately and starts burning and becomes ash. But whereas in the second case, the heat supplied from the candle flame is received by the water present inside the cup. So that water starts becoming hot. So the temperature is taken completely by the water. So the paper won't reach its ignition temperature easily. That's why it won't burn. It will be continuously heated. The water in the cup prevents the paper to reach its ignition temperature and hence it doesn't burn. That's the reason why the paper cup with water doesn't burn, because the heat supplied from the candle flame is absorbed, is taken completely by the water present inside the cup. So no heat energy is with the paper cup now. That's why its temperature doesn't rise and it won't reach its ignition temperature. That's why it is not catching fire. Okay, that's the reason. Next, what are inflammable substances? We told here the substances which are having very low ignition temperature and catches fire easily are called inflammable substances. What are those? The substances which catch fire at very low temperature and burn with flame are called inflammable substances. For example, LPG, liquefied petroleum gas, which we use at homes for our domestic purpose like cooking, and petrol, spirit, and some other organic substances. They are said to be inflammable, means they catch fire at very low temperatures and burns with the flames, and they may cause explosions too. These substances are called inflammable substances. Matchsticks. Have you seen any matchstick ever? All of us are very familiar with these matchsticks. In our homes, we use these matchsticks for lighting. Since ages, not only now, since ages, matchsticks are in use. Not only now, from the ancient time, these matchsticks are in use. Long ago, Egyptians used small pieces of pine wood dipped in sulfur as matches. But these days, matchsticks are a lot safer than those. They are made into very safe mode. Modern matchsticks are made up with a mixture of antimony trisulfide and potassium chlorate. So this matchstick tip, actually it is a wooden splint, and its tip is covered with antimony trisulfide and potassium chloride. The mixture of these two is mixed with glue and it is stick to the edge of this stick, wooden splint. It is used as matchstick. The head of this matchstick contains antimony trisulfide and potassium chloride. These two chemicals are present on the tip of this matchstick. So these are stick to this wooden splint by using certain glue mixed with it. Now the rubbing surface of this matchbox has powdered glass and some red phosphorus. So some red phosphorus is mixed with powdered glass powder, and these two are stick to this matchbox cover surface. Now, on striking the matchstick against the rough surface of this matchbox, then the red phosphorus present on the surface of this matchbox converts into white phosphorus and it reacts with the potassium chlorate present in the matchstick head and it ignites antimony trisulfide. So the combustion takes place and it starts burning. Okay, this is a chemical reaction occurs in the matchsticks. Okay, don't worry, just for our information it is given. Need not to remember these chemical formulae as we don't know. Okay, what are those? Antimony trisulfide and potassium chlorate. These two chemicals are present on the head of this matchstick, the tip of the matchstick, the black spot. contains these two. And the matchbox surface, the brown color surface at the edges, contains red phosphorus with some glass powder. Why this glass powder means to give that roughness. When matchstick is rubbed against it, then immediately that red phosphorus on the matchbox surface converts into white phosphorus. This reacts with potassium chlorate in the matchstick and it starts igniting. It ignites antimony trisulfide present in the matchstick. Immediately fire comes, it starts burning. In that way, matchstick catches fire. Okay, this is happening behind the matchstick burning. What are supporters of combustion? We have just seen what is meant by combustion. The burning of a substance in the presence of air. The burning of a substance in the presence of air is called combustion, which produces heat. Now, the gaseous environment that supports combustion of a combustible substance is called supporter of combustion. We said in the earlier cases, the combustion of any fuel or any combustible substance will occur only in the presence of air. To say in particular, in the presence of oxygen. That gaseous environment or that gas which is supporting the combustion of a fuel is called supporter of combustion. For example, air is the main supporter of combustion on the earth. It is the oxygen gas present in the air which supports the combustion. Oxygen gas supports the combustion. So we can say oxygen is a supporter of combustion. Oxygen is said to be supporter of combustion. In the presence of oxygen only, fuels will continue to burn. They burn and produce heat energy. This happens only in the presence of oxygen. That is why oxygen is called supporter of combustion. And one more gas, not only oxygen, one more gas is there which is supports combustion. That is nitric oxide, NO. Nitrogen oxide also you can say simply, but nitrogen forms so many oxides. So it is particular to be said as nitric oxide. It is another gas which supports combustion. Okay, just like the oxygen, it also supports combustion. But most of the chemicals reactions, most of the chemical combustion reactions occur in the presence of oxygen because it is available plenty in the atmosphere, whereas nitric oxide is not. Actually, we say here combustion occurs only in the presence of air or in the presence of oxygen only. But some chemical substances they continue to burn in the absence of air also. That we say combustion in the absence of air. Sometimes combustion takes place in the absence of air also. As let us say which are illustrated in the examples here. For example, magnesium ribbon continues to burn in the atmosphere of nitrogen, which is not a supporter of combustion. Yes, magnesium, the burning magnesium strip, if it is kept in the atmosphere of nitrogen, then also it continues to burn. Actually, the burning should put off in the presence of nitrogen because nitrogen is not a supporter of combustion, but it continues to burn in the presence of nitrogen also. One more, hydrogen gas burns in the atmosphere of chlorine to form hydrochloric acid. So one more it is here, the burning which occurs in the absence of air is burning of hydrogen gas in the presence of chlorine. These two gases react vigorously to form hydrochloric acid. So these are rare cases which occur where burning occurring in the absence of air. Okay. Now the factors that affect the rate of combustion, that speed of combustion. So the factors which are affecting the rate of combustion, one of them is size of the combustible particles. The smaller is the size of the combustible particle, the faster is the rate of the combustion. So if the size of the particles of combustible substance is low, that catches fire easily and burns with the faster rate. For example, coal dust catches fire very rapidly as compared to solid coal. So the pieces of coal may take time for combustion. But if you take a powdered coal or coal dust, it catches very fastly the fire and burns very faster than normal coal. Because in the coal dust, the particle size is very low. So each particle will catch fire very fastly and burns rapidly. So if the size is smaller for the combustible particles, faster will be the rate of combustion. Another one more example. Aluminium powder catches fire rapidly as compared to bar of aluminium. Okay. So size is smaller, speed of combustion will be greater. Next factor is nature of combustible substance. If the substance is inflammable substance, then it burns rapidly as compared to substances like coal or wood. Actually, these coal and wood are also combustible substances only. But certain substances are there which are having their ignition temperature at very low conditions, low temperatures. So those are said to be inflammable substances. They burn very rapidly compared to normal substances like coal and wood. Okay, so nature of the substance also affects the speed of combustion or rate of combustion. Next, petrol catches fire. For example, for this, petrol catches fire more rapidly as compared to wood. So if you start burning petrol and wood at the same time, petrol catches fire immediately and very rapidly and starts continuous burning, whereas wood takes a long time for burning, starts burning, isn't it? So based upon the nature of these substances also, speed of combustion depends. Next one, nature of gaseous environment. The gaseous environment determines the rate of combustion. Yes, if there is oxygen, then the combustion occurs faster. Let us say example here. For example, combustible substances burn at an extreme fast rate in the pure oxygen than in air, in which the concentration of oxygen is around 21% by volume. Okay, if you take the same substance, two pieces of two same combustible material, if you make them to catch fire in two different atmospheres, one which contains normal atmospheric air and the other one has pure oxygen. Now the sample of combustible material which is kept in the pure oxygen, it catches fire easily and burns with a very faster rate because there is pure oxygen which is completely supporter of combustion. So that substance will combust in the faster rate. Whereas the combustible material piece kept in the atmospheric air, it burns slowly comparatively because the composition of oxygen gas in the atmospheric air is only 21%. Remaining gas is nitrogen, as we know, other gases. So supporter of combustion is less in that. So the nature of the gaseous environment also affects the rate of combustion. Next, ignition temperature of combustible substance. This also affects the rate of combustion. The minimum temperature to which a combustible substance must be heated before it catches fire is called ignition temperature. Now, the lower the ignition temperature, the higher is the rate of combustion. So, a substance which is having low ignition temperature that catches fire easily and burns at faster rate. Okay. For example, substances like ether, alcohol, petrol, they have low ignition temperatures. All these substances they have their ignition temperatures below 50 degrees and hence they burn at faster rate. Whereas some other substances like wood and if you take some wood logs, these all they contain their ignition temperatures very high. So they should be heated for a long time at high temperatures. Then only they catch fire and starts burning. Okay, based upon the ignition temperature also, rate of combustion depends. The substances which are having low ignition temperature, they catch fire easily and burns at faster rate. Combustion occurs at faster rate for those. For example, alcohol, petrol, LPG, these burn at faster rate. Whereas the substance like wood logs, these all, they have high ignition temperature, they catch fire at very slow rate on long heating and they burn with a slow rate and compared to the remaining. Okay, this is about ignition temperature. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.